Hey guys, imagine a world with no grocery stores, no microwaves, no takeout, and definitely no pizza delivery. Instead, picture dense forests, vast savannas, rushing rivers, and endless skies stretching across continents untouched by roads or cities. This is the world of prehistoric humans, a place where survival was the ultimate goal, and food wasn't just about flavor or convenience, it was a matter of life and death. Tonight, we're going to step back tens of thousands, even hundreds of thousands, of years to explore what humans actually ate before civilization began. And believe me, it's not as simple as hunting a mammoth and eating berries on the side. The truth about prehistoric human diets is a fascinating story, full of surprises, clever survival strategies, and some shocking myths we all grew up believing. First, let's set the stage. Prehistoric humans weren't a single species but a variety of humans over millions of years. From Homo habilis, who lived around 2.4 million years ago, to the familiar Homo sapiens who started appearing around 300,000 years ago. Each of these humans faced different challenges, depending on climate, geography, and available resources. And while we often romanticize the caveman image, with a club in one hand and meat in the other, the reality was far more nuanced. Prehistoric humans were not just hunters, they were opportunistic eaters, brilliant adapters, and incredibly resourceful in finding food in a world that could be both generous and brutally unforgiving. So, what did they eat? Well, the first thing to understand is that prehistoric diets weren't uniform. It wasn't as if every human throughout the ages sat down to the same menu every day. Instead, what people ate depended heavily on their environment. In coastal areas, seafood might have been the primary source of protein. In forested regions, nuts, fruits, and roots were abundant. On open plains, herds of herbivores provided meat, bones for tools, and fat for energy. The flexibility in diet was key to survival, and this flexibility was one of the reasons humans thrived while countless other species disappeared. Archaeologists and anthropologists have pieced together evidence of prehistoric diets from a variety of sources. Fossilized bones tell us about the animals humans hunted and ate. Ancient teeth show patterns that reveal whether people gnawed on meat, chewed fibrous plants, or even used teeth as tools. Residues in ancient cooking pots, soil samples, and even preserved feces give clues about what prehistoric humans actually consumed. And when combined with studies of modern hunter-gatherer societies, we get an astonishingly detailed picture of what meals might have looked like tens of thousands of years ago. One of the most surprising findings is that prehistoric humans ate a far more diverse diet than many people assume. While we might think of the Mettitine caveman, early humans consumed a variety of plants, fruits, nuts, seeds, and even insects. Yes, insects. It might sound gross to us, but they were a high-protein, nutrient-dense food source that didn't require hunting a dangerous animal. Eating a handful of ants or termites might have been just as valuable as catching a small mammal, and it was often safer. This isn't just speculation. Archaeological evidence shows that insects were a consistent part of the diet in various parts of the world. Another fascinating aspect is how humans adapted to the availability of food throughout the seasons. Unlike today, where supermarkets give us strawberries in winter and tomatoes in January, prehistoric humans had to eat what nature provided at the moment. Spring brought a bounty of new plants and tender shoots. Summer offered fruits and berries. Autumn was harvest time for nuts and roots, and winter demanded reliance on stored foods or hunting larger game. This seasonal rhythm dictated not only what humans ate, but also their movement patterns, social organization, and survival strategies. Now, let's not forget about one of the most revolutionary tools in human dietary history, fire. Cooking food transformed human diets in ways we're only beginning to fully appreciate. Raw meat and plants can be difficult to digest and sometimes dangerous, but cooking softens fibers, breaks down toxins, and releases more nutrients. Imagine the first human discovering that roasting a root over a fire made it sweeter, easier to chew, and much more satisfying. That simple act of cooking not only changed the taste but also boosted nutrition and ultimately helped our brains grow larger. Some scientists argue that the increased energy from cooked food played a critical role in human evolution. So, every bite of roasted root or grilled fish was more than just a meal, it was a tiny evolutionary advantage. We also need to address some myths that have persisted in popular culture. The idea that prehistoric humans were constantly starving or only ate meat is misleading. While survival was never guaranteed, prehistoric diets were surprisingly abundant and varied in many regions. Early humans knew how to exploit their environment efficiently, and their diets were carefully balanced between carbohydrates, proteins, and fats, even if they didn't know it in the modern nutritional sense. And while hunting large game like mammoths or bison gets all the attention, these hunts were not daily events. A lot of daily calories came from gathered plants, nuts, and smaller game, forming a steady foundation for survival. Another important aspect to consider is social eating. Prehistoric humans were not solitary creatures. They lived in small groups or tribes. Sharing food was not just a kindness, it was essential for survival. Those who hunted successfully often shared with the group, ensuring that even members who were sick, injured, or unsuccessful in hunting had enough to eat. This social aspect of eating strengthened bonds and improved the overall resilience of the group. In a way, eating together was one of the first forms of community support. Systems a prehistoric version of looking out for your neighbors. And of course, the diet was not just about nutrition. Certain foods had cultural or symbolic importance. Some tribes may have reserved special foods for rituals, ceremonies, or displays of status. While meat might have been prized, certain plants or herbs could have been considered sacred, medicinal, or even magical. Food was intertwined with survival, spirituality, and social structure, demonstrating that even tens of thousands of years ago, humans recognized the importance of more than just calories. Finally, let's touch on the long-term effects of these diets. Skeletal remains show that prehistoric humans were generally robust, with strong bones and teeth adapted to a demanding diet. They experienced fewer of the chronic diseases we see today, such as diabetes or heart disease, which are often linked to modern processed foods. However, life was not easy. Accidents, infections, and nutritional scarcity still posed significant risks. But when food was available, it was nutrient-dense, varied, and perfectly suited to the human body as it evolved. So, as we begin this journey into prehistoric diets, remember this: what we eat today is the result of millions of years of experimentation, adaptation, and survival. From roasted roots to freshly caught fish, from nuts to insects, every meal was a lesson in creativity, resilience, and the sheer will to live. Over the next chapters, we'll explore the specifics: how humans hunted, gathered, cooked, and even stored their food. We'll dive into regional differences, seasonal strategies, and some of the most surprising facts about what our ancestors really ate. And along the way, you might find yourself rethinking what you consider normal food today. Long before agriculture, humans survived as hunters and gatherers, moving through landscapes in search of whatever food nature offered. Hunting wasn't just a casual pastime or sport, it was a matter of survival, requiring skill, patience, and knowledge passed down through generations. Imagine tracking a herd of deer across a vast open plain, reading subtle signs like broken branches, footprints in soft soil, and distant sounds of movement. Every step mattered, every decision could mean the difference between a successful hunt and a wasted day. Early humans had a surprisingly diverse toolkit for hunting: simple wooden spears, sharpened stones, and later, more advanced tools like otlots and bows allowed them to hunt efficiently. They didn't just rely on brute strength, they studied animal behavior, learned seasonal patterns, and often collaborated in groups. Coordinated strategies were common. Some tribes would drive animals toward natural traps, cliffs, or ambush points, maximizing the chances of a successful kill while minimizing personal risk. Even small game like rabbits or birds required clever techniques, demonstrating that prehistoric humans were as much strategists as they were hunters. But hunting alone didn't sustain them. Gathering played an equally critical role in the diet. Nuts, seeds, roots, tubers, fruits, and edible plants provided essential vitamins, minerals, and energy. For many groups, especially in forested or resource-rich regions, plant foods could make up the majority of daily caloric intake. Gathering wasn't haphazard. It required intimate knowledge of the local environment: which berries were safe to eat, which roots needed cooking to remove toxins, which nuts were ripe and easy to crack. Mistakes could be deadly, so learning and memorizing these details was crucial. Interestingly, hunting and gathering weren't just individual tasks, they were social activities. Groups often split responsibilities based on age, skill, and experience. Younger members might collect fruits or small game, while seasoned hunters tracked larger prey. This division of labor ensured efficiency and survival. It also fostered social bonds, as shared knowledge about the land and its resources became part of the group's culture. Meals weren't just about nutrition, they were opportunities to strengthen trust, teach survival skills, and reinforce the social structure. The types of animals hunted varied widely depending on region and era. In colder climates, humans pursued large herbivores like mammoths, reindeer, and bison. These hunts were dangerous and required careful planning, often involving dozens of individuals. Success meant a substantial supply of meat, fat, and hides that could sustain a group for weeks. In warmer or tropical regions, smaller mammals, reptiles, and birds were more common. Coastal communities relied heavily on fish, shellfish, and even aquatic plants, demonstrating the adaptability of early humans to different environments. Another fascinating aspect of hunting was the use of traps and tools to minimize risk. Pitfall traps, snares, and simple netting allowed humans to catch prey with less direct confrontation. Archaeological evidence shows that humans developed sophisticated knowledge of animal behavior to create effective traps. For example, certain pitfall traps were carefully camouflaged and positioned along natural animal paths. Others involved luring animals with bait or sounds. These strategies required patience and understanding, a far cry from the idea that prehistoric hunting was purely about chasing and killing. Gathering, while seemingly easier than hunting, had its own set of challenges. Not all plants were safe to eat, and some required preparation to remove toxins. For example, many tubers and roots needed to be roasted or soaked to eliminate harmful compounds. Even nuts and seeds often required cracking or drying to be edible. Prehistoric humans developed remarkable ingenuity in processing food. Evidence of grinding stones, roasting pits, and rudimentary ovens suggests that people weren't just gathering, they were experimenting with ways to maximize nutrition and safety. Seasonal variation also played a huge role in hunting and gathering. Early humans had to understand not just what to eat, but when to eat it. Certain fruits and nuts were only available during specific months, while animal migrations dictated hunting patterns. Tracking these cycles was critical. Groups often moved seasonally, following game or harvesting plants at their peak. This nomadic or semi-nomadic lifestyle allowed them to exploit resources efficiently, ensuring a relatively steady supply of food despite environmental fluctuations. The caloric and nutritional value of hunting and gathering was surprisingly balanced. Large herbivores provided protein and fat essential for energy and brain development. Fish, especially fatty fish like salmon, offered omega-3 south crucial for cognitive function. Plants supplied carbohydrates, fiber, and micronutrients necessary for health and longevity. Even insects contributed protein, fats, and minerals. Early humans didn't need a supermarket. They had a diverse, nutrient-rich diet that adapted to what nature provided. Hunting and gathering also shaped human culture and innovation. The need to track animals, identify edible plants, and prepare food safely drove technological development. Sharpened stone tools, bone needles, fire management, and later, storage techniques all originated from the practical demands of securing food. These innovations were often shared within groups, creating a foundation for learning, teaching, and eventually, more complex societal structures. Interestingly, archaeological evidence suggests that hunting and gathering weren't always solely about survival. They had recreational and ritualistic dimensions as well. Some prehistoric art depicts animals in ways that hint at symbolic or spiritual significance. Hunting might have involved ceremonies, dances, or offerings to ensure success. Gathering certain plants or herbs may have had medicinal or ritualistic purposes. Food was more than just calories. It was entwined with the worldview, beliefs, and daily life of prehistoric humans. Another aspect often overlooked is the efficiency of early humans as hunters and gatherers. Contrary to popular belief, prehistoric humans spent fewer hours hunting or gathering than one might expect. Studies of modern hunter-gatherer societies suggest that a few hours of focused effort often provided enough food for the entire day. This efficiency left time for other activities: toolmaking, socializing, teaching, exploring, and resting. Life was demanding, yes, but it wasn't non-stop toil. Humans were smart, adaptable, and strategic in how they acquired food. Hunting and gathering also influenced social hierarchy and gender roles. While there's no single rule across all prehistoric societies, evidence suggests that roles were often divided in ways that complemented each other. Men frequently hunted larger game, while women and children gathered plants, fruits, and small animals. These roles weren't just about biology, they reflected the optimal allocation of skills, energy, and risk. Importantly, both tasks were vital, and both contributed to the survival of the group. Finally, it's worth noting how hunting and gathering impacted human evolution. The need for endurance, strategy, and cooperation drove physical and cognitive development. Tracking animals over long distances required stamina and spatial awareness. Identifying edible plants demanded memory and observational skills. Coordinated hunts fostered communication, planning, and social cohesion. Every successful hunt and gathered meal wasn't just survival, it was practice in problem-solving, innovation, and community living. In essence, hunting and gathering were the foundation of prehistoric diets and lifestyles. They were not random acts of scavenging, but carefully managed strategies honed over millennia. They shaped technology, social structures, culture, and even human biology. Understanding this gives us a richer perspective on what it meant to eat and survive in a world without supermarkets, refrigerators, or packaged foods. Every meal required knowledge, skill, and cooperation, and every bite connected humans directly to the land, the seasons, and the animals around them. Long before humans cultivated vast fields or stocked grocery shelves, the wild offered a bounty of fruits, nuts, and vegetables that were essential to survival. For prehistoric humans, these foods were more than just snacks. They were a steady source of calories, vitamins, and minerals, often forming the backbone of the diet, especially in times when hunting was scarce or dangerous. Imagine wandering through a dense forest or a sun-drenched savanna, your eyes scanning the environment for ripe berries, edible roots, or fallen nuts. Each discovery was a small triumph, a chance to nourish the body without the uncertainty of the hunt. Fruits were among the most eagerly sought-after foods. Berries, apples, figs, and wild melons provided natural sugars that delivered quick energy. They were portable, easy to eat, and often grew in abundance during certain seasons. But gathering fruit wasn't always as simple as plucking it from a branch. Some fruits grew high in trees, requiring climbing skills or clever use of sticks and tools to harvest them. Others had tough skins, hidden seeds, or bitter toxins that needed to be carefully removed. Over time, humans learned which fruits were safe to eat, raw, which required processing, and which were best avoided. Nuts were another crucial component of prehistoric diets. High in fat, protein, and essential nutrients, they provided sustained energy and helped early humans endure long treks, harsh climates, and the physical demands of hunting and gathering. Almonds, walnuts, hazelnuts, and chestnuts were commonly collected, often in large quantities during autumn to prepare for leaner months. Gathering nuts wasn't merely a matter of picking them up. Humans had to recognize when they were ripe, crack hard shells, and store them carefully to prevent spoilage. Archaeological evidence shows that prehistoric people may have even developed rudimentary storage techniques, such as burying nuts in cool soil or placing them in hollowed-out containers to preserve them for months. Vegetables and roots were equally important. Tubers, bulbs, leafy greens, and other wild vegetables offered vital nutrients like fiber, vitamins, and minerals that meat alone could not provide. Roots like wild carrots, parsnips, and yams were often dug up with simple tools or even hands, cleaned, and sometimes roasted or boiled over fire to make them more digestible. Leaves and shoots were gathered for salads, soups, or as supplements to stews made from meat and other plants. Even grasses and seeds were used in some regions, ground into pastes or porridge-like dishes to create a more substantial and filling meal. Seasonality dictated the availability of fruits, nuts, and vegetables, creating a natural rhythm to the prehistoric diet. Spring brought tender shoots and early berries. Summer offered a variety of fruits, wild greens, and legumes. Autumn was harvest time for nuts and late-season fruits, and winter forced reliance on stored or preserved foods. This natural cycle not only influenced what people ate, but also shaped their movements, settlement patterns, and social behaviors. Groups often moved from one area to another to follow seasonal abundance, turning food gathering into a dynamic and strategic part of life. The nutritional value of these plant-based foods cannot be overstated. While meat provided protein and fat, Fruits, nuts, and vegetables supplied essential carbohydrates, fiber, and micronutrients critical for brain function, immune support, and overall health. Modern research suggests that early humans who relied heavily on plant foods often had strong bones, healthy teeth, and fewer instances of chronic diseases associated with modern processed diets. The balance of plant and animal foods created a diet that was nutrient-dense and highly adaptable to environmental changes. Humans also developed innovative ways to process and enhance plant foods. Roasting tubers over fire made them sweeter and easier to digest, while grinding seeds and nuts into pastes or flour allowed for more versatile meals. Some communities may have even experimented with fermentation, creating early forms of preserved or slightly alcoholic foods. These practices not only improved taste and nutrition, but also extended the shelf life of seasonal foods, ensuring survival during times when fresh resources were scarce. Interestingly, some fruits and vegetables held cultural or symbolic significance. Certain plants were considered medicinal, used to treat ailments or boost energy. Others played roles in rituals, celebrations, or social gatherings, highlighting the connection between food, health, and culture, even in prehistoric times. For example, brightly colored berries might have been seen as symbols of vitality, while aromatic herbs could carry spiritual or protective associations. Food was never just fuel, it was deeply woven into the social and spiritual fabric of human life. The act of gathering itself required keen observation, memory, and patience. Early humans had to recognize not just which plants were edible, but also where and when they grew. They learned to read subtle environmental cues, such as the color of leaves, the firmness of fruit, or the presence of insects, to determine ripeness. They memorized locations where particular plants thrived and revisited these spots seasonally, creating a kind of mental map of edible resources. This intimate knowledge of the environment reflects a sophisticated understanding of ecosystems that was essential for survival. Moreover, gathering was often a social activity. Women and children frequently took the lead in collecting plant foods, while men focused on hunting. This division of labor wasn't rigid but practical, allowing the group to maximize efficiency. Sharing gathered foods reinforced social bonds and ensured that everyone, from elders to the youngest members, had access to vital nutrition. In many ways, gathering was a form of teamwork, knowledge sharing, and community building, as much as it was a means of sustenance. The diversity of plant foods also played a role in reducing risk. Relying solely on one type of food could be dangerous. If a fruit crop failed or a tuber patch was over-harvested, starvation could follow. By consuming a variety of fruits, nuts, and vegetables, early humans created a buffer against scarcity. This dietary diversity was an early form of risk management, demonstrating foresight and adaptability. In some regions, prehistoric humans even modified their environment to enhance plant availability. They might clear small patches of land to encourage the growth of desired plants or protect certain areas from overharvesting. These early forms of proto-agriculture foreshadowed the eventual domestication of plants thousands of years later. While still far from organized farming, these practices highlight the proactive strategies humans employed to secure essential plant foods. It's also fascinating to note the interplay between plant foods and hunting. Gathering often supplemented the diet when hunting was unsuccessful, providing a reliable source of calories. Conversely, knowledge of plant availability could influence hunting patterns. Hunters might focus on areas rich in edible plants to ensure that the group had a balanced diet even if meat was scarce. This synergy between hunting and gathering reflects the holistic approach early humans took to survival, integrating multiple food sources into a coherent strategy. Finally, the sensory experience of fruits, nuts, and vegetables shaped human preferences and perhaps even evolution. Sweetness, crunchiness, bitterness, and aroma were not just enjoyable, they were indicators of ripeness, safety, and nutritional value. Developing a palate attuned to these cues helped early humans identify high-quality foods, avoid toxins, and make the most of seasonal abundance. In a way, our modern taste preferences are a legacy of these prehistoric dietary experiences, shaped by countless generations learning from nature. In summary, fruits, nuts, and vegetables were far more than simple side dishes. In prehistoric diets they were vital, versatile, and deeply integrated into daily life. They provided essential nutrition, influenced movement and social organization, fostered innovation in food processing, and even carried cultural significance. For early humans, understanding and mastering the plant world was just as critical as mastering the hunt. Every berry picked, every root dug, and every nut cracked was a step toward survival, health, and the eventual development of human civilization. One of the most revolutionary developments in human history wasn't a tool, a weapon, or a shelter, it was fire. Fire transformed life in ways that went far beyond warmth and protection. It changed the very nature of food itself, altering taste, digestibility, nutrition, and even social structure. Imagine the first human who discovered that placing a root or piece of meat near the fire made it sweeter, easier to chew, and surprisingly satisfying. That simple observation was nothing short of a culinary revolution. Cooking food allowed early humans to extract more energy from what they ate. Raw meat and tough fibrous plants required significant chewing and digestion, but cooking broke down cellular structures, making nutrients more bioavailable. Starches in tubers, for example, became easier to digest when roasted or boiled, providing more calories with less effort. Protein in meat was partially denatured, meaning the body could absorb it more efficiently. Fat, the most calorie-dense nutrient, was easier to process as well. Some researchers argue that this increase in available energy from cooked food played a crucial role in the evolution of larger human brains. Direct link between fire, food, and intelligence. Fire also made previously inedible or toxic foods safe to eat. Many wild plants contain natural compounds that can cause illness if consumed raw. Early humans quickly learned which plants needed roasting, boiling, or prolonged heating to neutralize these toxins. Over time, this knowledge became part of collective cultural wisdom, passed down through generations. The ability to safely process food opened up new dietary possibilities and reduced reliance on risky hunting or limited seasonal resources. The social aspect of cooking cannot be overstated. Fire became a gathering point, a center of community life. Around the flickering glow of a fire, humans could cook together, share meals, tell stories, and teach younger members about survival skills. Meals evolved from simple acts of consumption to communal experiences. Sharing food around a fire strengthened bonds, reinforced social hierarchies, and provided opportunities for teaching and learning. In a way, fire transformed eating into a social ritual, laying the foundation for traditions that persist in modern culture. Archaeological evidence shows that humans used fire for cooking as early as 400,000 years ago, and possibly even earlier. Hearths, fire pits, and charred remains of food provide clues about how prehistoric people manipulated fire for culinary purposes. These controlled fires were more than simple flames, they represented mastery over a powerful natural element. Humans learned to start, maintain, and direct fire, a skill that required observation, patience, and ingenuity. Maintaining a fire wasn't easy. It demanded constant attention and knowledge of fuels, airflow, and safety, further highlighting the sophistication of early human societies. Cooking also expanded dietary options dramatically. Tough roots became tender, wild grains became digestible, and even insects and small animals could be consumed more safely and pleasantly. Foods that would have been difficult or unpalatable raw suddenly became viable, increasing both caloric intake and nutrient diversity. In regions where meat was scarce, fire enabled humans to maximize the utility of plant foods, nuts, and seeds. In essence, cooking made food more versatile and survival more attainable. Interestingly, the introduction of cooking likely influenced hunting strategies as well. Since cooked food could be stored longer and consumed more efficiently, humans could plan hunts with greater precision, saving high-value foods for special occasions or lean periods. Fire also allowed early humans to cook large quantities at once, facilitating communal eating and strengthening social cohesion. This interplay between fire, cooking, and group dynamics illustrates how a single technological advance can ripple through multiple aspects of life, shaping behavior, culture, and survival. Fire also provided warmth and safety, enabling humans to inhabit colder climates. With the ability to cook food and maintain body temperature, humans expanded into environments that would have been otherwise inhospitable. This geographic expansion required further dietary adaptation, as new regions presented unfamiliar plants and animals. Cooking, therefore, was not merely about flavor, it was a critical tool for human migration and ecological dominance. The sensory experience of cooked food also had profound implications. The aroma, texture, and flavor of roasted, boiled, or smoked food likely influenced preferences, guiding early humans toward calorie-dense and safe options. This early form of taste education helped humans identify which foods were nourishing and enjoyable, reinforcing behaviors that enhanced survival. Even today, our love for roasted flavors, caramelized sugars, and smoked meats echoes the ancient lessons learned around prehistoric fires. Another fascinating aspect of fire and cooking is preservation. Roasting, smoking, and drying foods over heat extended their shelf life, creating a buffer against scarcity. Fish, meat, and plant materials could be stored for days, weeks, or even months in some cases, allowing groups to survive periods of low resource availability. This early experimentation with food preservation foreshadowed the techniques that would later become critical in agricultural societies. Cooking also encouraged experimentation and innovation. Early humans learned to combine foods, mix flavors, and explore textures. Simple stews, roasted roots, or charred meats may have been the prehistoric equivalent of culinary creativity. These experiments weren't done for luxury, they were practical solutions to improve digestibility, safety, and energy intake, but they demonstrate the inventive mindset of our ancestors. Over generations, these practices became ingrained cultural knowledge, forming the basis for regional culinary traditions and dietary habits. Fire, of course, came with risks. Uncontrolled flames could destroy habitats, injure individuals, or attract predators. Early humans had to balance the benefits of fire with its dangers, developing strategies for safe use, containment, and relocation. This constant awareness further honed cognitive skills, planning, and group coordination, showing that the mastery of fire was not just a technological advance, it was a cognitive and social one. Finally, the impact of fire and cooking on health is notable. Cooked foods reduced the energy expenditure required for digestion, lowered the risk of illness from pathogens, and increased nutrient absorption. These benefits likely contributed to longer lifespans, better brain development, and more robust populations. In essence, the simple act of cooking around a fire may have played a central role in the evolutionary success of Homo sapiens. In conclusion, fire transformed prehistoric diets from raw and limited to versatile, nutritious, and socially significant. Cooking allowed humans to extract more energy, reduce toxins, extend food availability, and create communal rituals that strengthened social bonds. Every roasted root, every smoked fish, and every shared meal around the flickering glow of a fire was a testament to human ingenuity, resilience, and adaptability. Without fire, human history might have looked very different, less expansive, less social, and certainly less flavorful. Life in prehistoric times was deeply intertwined with the rhythms of nature. Unlike today, where we can buy strawberries in winter or enjoy imported fruits year-round, prehistoric humans had to eat what the land and season provided. Their diets changed with the months, the climate, and the environment they inhabited. Understanding these seasonal and regional differences is essential to grasp the true complexity of prehistoric human diets. In temperate regions, spring was a time of renewal. Tender shoots, fresh leaves, and early fruits began to appear. Humans would eagerly seek out these first signs of edible plants after a long winter of limited options. Roots stored over winter, nuts cached in dry places, and preserved meats would supplement the emerging greenery. Spring wasn't just about survival, it was a time to replenish energy, regain strength, and prepare for the long days of summer. The awakening of the landscape dictated movement patterns, as groups traveled to areas where fresh resources were sprouting, ensuring access to nutrient-rich foods. Summer brought abundance. Fruits ripened on bushes and trees, leafy greens flourished, and small game and fish were plentiful. This season allowed prehistoric humans to diversify their diets more than any other time of year. Berries, plums, figs, and wild melons provided sweet energy, while leafy plants contributed essential vitamins and minerals. Aquatic resources became especially important in coastal or riverine communities, where fish, shellfish, and crustaceans were accessible. Hunting also became more productive, as animals were often more active and easier to track. Summer was a season of plenty, but it required careful management to avoid waste, overharvesting, or missed opportunities. Autumn marked the harvest season. Nuts ripened, seeds matured, and many tubers became fully developed underground. This was a critical time for preparation, as winter would soon limit the availability of fresh foods. Prehistoric humans collected nuts, acorns, chestnuts, and other energy-dense foods, often in massive quantities. They stored these foods in caches, pits, or protected areas to survive the lean months. Autumn also provided an opportunity for hunting larger game, as many herbivores fattened in preparation for winter, offering a higher caloric yield. Successful hunts during this season could mean a stable food supply for weeks or months. Winter posed the greatest challenges. Cold, snow, and scarcity made hunting and gathering far more difficult. Humans relied on stored foods, preserved meats, nuts, and roots collected earlier. In some regions, they might also supplement diets with hardy plants, evergreen leaves, or underground roots that survived frost. The scarcity of fresh resources required careful rationing and planning. Survival depended not just on individual skill but on group coordination, as cooperation became essential for managing stored foods and maintaining warmth. Communities huddled around fires, shared meals, and relied on collective knowledge to endure harsh conditions. Regional differences further complicated prehistoric diets. Coastal communities had diets rich in fish, shellfish, seaweeds, and other marine resources. These populations often developed specialized tools for fishing, such as hooks, nets, and spears, and their diets reflected the availability of abundant aquatic protein. Inland communities, by contrast, relied more heavily on terrestrial animals, wild plants, and gathered nuts and fruits. Forested regions offered berries, roots, and small game, while open plains allowed for large game hunting. Each environment shaped the diet, demonstrating human adaptability and ingenuity. Climate also played a critical role. In colder regions, high-fat foods like mammoth, reindeer, or seal provided the necessary energy to survive freezing temperatures. In warmer climates, lighter foods, fruits, vegetables, insects, and small game helped maintain hydration and avoid overheating. Even within the same region, microclimates affected food availability. River valleys, mountain slopes, and coastal plains all offered distinct resources, creating a patchwork of dietary possibilities. Humans had to understand these nuances intimately to thrive. Migration patterns were often driven by these seasonal and regional food differences. Groups moved to follow game, harvest ripening plants, or access freshwater sources. Nomadic or semi-nomadic lifestyles allowed prehistoric humans to exploit the land efficiently, ensuring a continuous supply of diverse foods. These movements also facilitated knowledge sharing, as groups encountered new environments, discovered novel plants or animals, and learned from each other's survival strategies. In essence, prehistoric diets were dynamic, constantly adapting to time and place. Archaeological evidence supports this complexity. Fossilized remains reveal variations in diet depending on region and season. Isotopic analysis of bones can indicate the proportion of plant versus animal foods consumed. Residues in cooking pits and storage containers show seasonal use of specific foods. Even dental wear patterns reflect seasonal consumption, as the textures and abrasiveness of different foods leave telltale marks. Together, these clues paint a detailed picture of how prehistoric humans managed the interplay between environment, season, and nutrition. The challenge of seasonal variation encouraged innovation. Humans developed storage techniques such as drying, smoking, or burying foods to extend availability. They learned to combine different foods to balance nutrition when preferred items were scarce. Early experimentation with preservation foreshadowed later developments in agriculture and food processing, demonstrating the link between necessity and creativity. Seasonal rhythms also influenced social organization. Certain tasks were aligned with specific times of year: spring for gathering tender greens and early fruits, summer for abundant hunting and fishing, autumn for harvesting and storage, and winter for rationing and conserving resources. These cycles created a structured approach to survival, with each member of the group contributing according to skill, age, and experience. Food acquisition and preparation became central to social cohesion and planning, as the success of the entire group often depended on the collective understanding of these seasonal patterns. Regional variation also impacted the types of foods consumed in surprising ways. In some areas, prehistoric humans exploited aquatic plants, mollusks, or crustaceans as staples, In mountainous regions, hardy tubers and nuts formed the bulk of the diet. In tropical forests, a wide array of fruits, seeds, and small animals provided essential nutrition. Even predators influenced diet indirectly. Humans had to compete for resources or hunt prey that was not actively defended by larger carnivores. Understanding local ecology was essential, and it shaped both daily survival and long-term adaptation. Moreover, these differences created a rich tapestry of dietary knowledge. Groups in different regions developed specialized knowledge about which plants were edible, how to prepare them, and how to combine them with hunted foods. This expertise was shared within communities and across generations, forming the foundation for cultural practices, food, taboos, and culinary traditions that would eventually evolve into more complex agricultural societies. In some cases, food scarcity and harsh seasons prompted remarkable problem-solving. Humans learned to store fat-rich meats, ferment fruits, or even grind nuts and seeds into pastes to create long-lasting calorie-dense foods. These strategies reduced the impact of lean periods and ensured that groups could survive until the next season of abundance. The interplay of seasonal availability, regional resources, and innovative storage techniques highlights the sophisticated approach prehistoric humans took toward managing their diets. In conclusion, prehistoric diets were far from static. They changed with the seasons, adapted to the local environment, and responded to the availability of plants, animals, and other resources. Early humans were keen observers of nature, understanding the nuances of regional ecosystems and timing their activities to maximize nutrition and survival. Seasonal and regional differences were not obstacles, they were opportunities for creativity, learning, and innovation. Every movement, harvest, and hunt was a strategic decision, ensuring that communities thrived in a world that demanded flexibility, knowledge, and resilience. When we think of prehistoric humans, our imagination often runs wild. Movies, cartoons, and popular culture have given us the image of grunting cavemen, constantly chasing mammoths with crude clubs, wearing nothing but animal skins, and living in a world of relentless danger. While entertaining, these depictions are far from accurate. The reality of prehistoric diets, survival, and daily life is far richer, more nuanced, and surprisingly sophisticated. To truly understand what early humans ate and how they lived, we need to separate myth from reality. One of the biggest myths is that prehistoric humans were exclusively meat. The caveman diet popularized in modern fad nutrition often exaggerates the proportion of meat consumed by early humans. Archaeological evidence paints a different picture. Plant-based foods, nuts, seeds, roots, and vegetables formed a substantial part of their diet, sometimes constituting the majority of calories, depending on the region and season. Meat was valuable, yes, but it was not the sole or even primary source of sustenance for many communities. Another misconception is that hunting was a constant, daily struggle for survival. While hunting large game was dangerous and required skill, early humans were strategic about it. They used knowledge of animal behavior, seasonal patterns, and tools to maximize efficiency. Moreover, hunting was often supplemented by foraging, fishing, and small game trapping, ensuring a more reliable and balanced food supply. Survival wasn't about endless running or constant confrontation. It was about observation, planning, and adaptability. The popular image of prehistoric humans as disorganized or primitive is also misleading. Evidence shows that they were highly intelligent, capable of tool-making, fire management, and coordinated group activities. They developed strategies for hunting, gathering, and food storage that required planning, foresight, and cooperation. Their social organization and shared knowledge allowed them to thrive in environments that were challenging and often unpredictable. Far from being mindless brutes, they were innovative problems, constantly learning from their environment. A common myth involves the idea that prehistoric humans ate whatever they could find indiscriminately. In reality, humans were selective and knowledgeable about their food. They understood which plants were edible, which parts of animals were most nutritious, and how to process food to enhance digestibility and safety. Mistakes could be deadly, so learning and precision were essential. This careful selection and preparation of food reflects a sophisticated understanding of ecology and nutrition, honed over countless generations. Another popular misconception is that early humans were constantly starving or malnourished. While life was undoubtedly challenging and periods of scarcity occurred, Archaeological and anthropological evidence suggests that many communities had access to a surprisingly diverse and nutrient-rich diet. Human physiology was adapted to periods of feast and famine, and the combination of hunting, gathering, and fire-cooked foods provided sufficient energy and nutrients. Early humans were not starving most of the time. They were skilled at managing resources to maintain health and survival. The one-size-fits-all view of prehistoric diets is also inaccurate. Diets varied dramatically depending on location, climate, and season. Coastal populations consumed fish, shellfish, and sea plants. Forest dwellers relied heavily on nuts, fruits, and roots. Open plains encouraged large game hunting, while desert or arid regions demanded reliance on drought-resistant plants and small animals. Prehistoric diets were adaptive, reflecting an intimate understanding of the environment and the available resources. No single diet defined all humans, and diversity was key to survival. Many myths also exaggerate the dangers of plant foods. While some wild plants were toxic, early humans had an impressive knowledge of edible species. They knew which parts were safe to consume, how to prepare them, and how to combine them with other foods for optimal nutrition. Over time, this knowledge became a cultural legacy, passed down through generations, ensuring both safety and survival. In fact, plant foods often formed the backbone of the diet, particularly during lean hunting seasons. Fire and cooking are another area where myths diverge from reality. Some assume that early humans only discovered fire accidentally or used it rarely. Archaeological evidence suggests otherwise. Controlled use of fire was widespread, and cooking played a crucial role in daily life. It allowed humans to process otherwise inedible foods, preserve surplus, and enhance nutrition. Far from being a rare luxury, cooking was an essential survival tool. Integrated into the rhythm of daily life and seasonal cycles, another myth concerns the simplicity of meals. Modern depictions often show prehistoric humans gnawing on raw meat or biting into a root without preparation. The reality is far more complex. Humans roasted, boiled, dried, and sometimes even fermented foods. They combined plant and animal resources to create balanced meals. These preparation techniques required planning, knowledge, and creativity, demonstrating that prehistoric diets were both practical and sophisticated. Social myths also abound. Many imagine prehistoric humans as entirely solitary, only coming together to hunt. In reality, communal eating, food sharing, and cooperative gathering were central to survival. Knowledge about edible plants, animal behavior, and preparation techniques was passed down socially. Food strengthened social bonds, reinforced group hierarchies, and promoted collective well-being. Prehistoric life was deeply social, and food was a cornerstone of that social structure. Even the myth of constant danger doesn't capture the full picture. While predators, natural disasters, and scarcity were real threats, early humans developed strategies to mitigate risk. Knowledge of seasonal and regional resources, careful storage, and cooperation allowed them to thrive. Risk was managed, not ignored, and survival was often a product of intelligence, adaptability, and foresight rather than brute strength alone. Finally, the idea that prehistoric diets were monotonous or boring is also false. Early humans consumed an incredible diversity of foods, from nuts and berries to roots, tubers, small and large game, fish, insects, and more. They experimented with preparation techniques, fire, and preservation. Their diets were dynamic, seasonal, and regionally adapted, a far cry from the simplistic Matandrus image. In conclusion, separating myths from reality reveals a fascinating and sophisticated picture of prehistoric diets. Early humans were intelligent, adaptable, and highly skilled in finding, processing, and consuming food. They were not starving brutes, nor indiscriminate eaters. They were strategic, innovative, and deeply connected to the rhythms of nature. Understanding this reality gives us a far richer appreciation for the challenges, ingenuity, and resilience of our ancestors, showing that what we eat today is built on millions of years of human experience, experimentation, and survival. Prehistoric diets had a profound impact on human health, shaping bodies, brains, and lifespans long before the advent of modern medicine. Unlike today, where processed foods, refined sugars, and sedentary lifestyles dominate, early humans consumed a diet that was nutrient-dense, varied, and directly linked to survival. Every bite of meat, every gathered berry, and every roasted root contributed not only to energy but also to overall well-being. Understanding the health implications of these diets gives us insight into the evolutionary journey of Homo sapiens. One of the most striking effects of prehistoric diets was their balance. Protein from meat, fish, and small game provided essential amino acids needed for growth, repair, and brain development. Fats, particularly from fatty fish, nuts, and large herbivores, supplied high-energy fuel and were critical for neurological development. Carbohydrates from fruits, vegetables, and tubers provided quick energy and essential fiber, aiding digestion. This natural balance created a diet that supported robust physical and cognitive development. Bone health was strongly influenced by prehistoric diets. Nutrient-rich foods high in calcium, magnesium, phosphorus, and vitamin D promoted strong skeletal structures. Evidence from fossilized bones shows that early humans had robust skeletons and well-developed musculature, reflecting both diet and active lifestyles. Unlike modern populations, whose diets sometimes lack essential nutrients, prehistoric humans naturally obtained what their bodies required through a diverse, whole-food diet. Dental health offers another fascinating perspective. While prehistoric humans experienced some tooth wear due to gritty foods, they had remarkably low levels of cavities compared to modern populations. The absence of refined sugars and processed carbohydrates meant that oral bacteria did not thrive in ways that cause widespread decay. Chewing fibrous plants and raw foods also contributed to strong jaws and teeth. Even small imperfections in teeth were managed naturally through diet, and the mechanical action of eating whole foods. Prehistoric diets also supported immune function. Nutrient-dense foods rich in vitamins, minerals, and antioxidants strengthened the body's ability to resist infections. Consuming a wide variety of plants, fruits, and nuts introduced a range of micronutrients, while animal products provided essential proteins and fats. This diversity helped early humans maintain resilience against pathogens, seasonal changes, and environmental stresses. Nutrition and immunity were directly linked, and survival often depended on consuming the right foods at the right time. Cognitive development is another area profoundly influenced by prehistoric diets. Essential fatty acids, particularly omega-3 from fish and certain nuts, are critical for brain growth and function. Protein and minerals from meat and plant foods supported neurotransmitter production, memory, and problem-solving abilities. The high energy yield from cooked foods allowed the human brain, which is metabolically demanding, to grow larger and more capable than those of other primates. In a sense, fire, cooking, and a nutrient-rich diet created the conditions for the cognitive leaps that define our species. Energy levels and physical endurance were directly tied to diet. Hunting, gathering, and foraging demanded long hours of movement and sustained effort. The combination of high-energy foods like fat, protein, and carbohydrates from plants enabled humans to maintain stamina over long distances. This diet also facilitated efficient recovery from injuries or illness, as the body had access to essential nutrients needed for repair. Prehistoric humans were, in many ways, finely tuned endurance athletes. With diet as their fuel, reproductive health was equally influenced by nutrition. Adequate intake of protein, fat, and essential micronutrients supported fertility, healthy pregnancies, and lactation. Malnutrition could lead to reduced fertility or complications, but the diversity of the prehistoric diet often ensured sufficient nourishment. Seasonal variations in food availability may have even influenced reproductive cycles, demonstrating a complex interplay between environment, nutrition, and human biology. Interestingly, despite the challenges of prehistoric life, many chronic diseases that plague modern societies were rare or absent. Heart disease, type 2 diabetes, and obesity were uncommon because diets were natural, minimally processed, and calorie-dense in the right ways, without excess sugars or refined grains. While early humans faced acute risks like injury, infection, or starvation, chronic lifestyle-related conditions were virtually non-existent. Their diets, combined with active daily life, created resilience against long-term degenerative conditions. The gut microbiome was also shaped by the diversity of prehistoric diets. Consuming a wide range of fibrous plants, fermented foods, and varied proteins encouraged a rich and balanced microbial community in the digestive tract. A healthy microbiome supports digestion, nutrient absorption, immune function, and even mental health. By eating a diet directly sourced from nature, early humans naturally cultivated a gut environment conducive to overall wellness. Moreover, prehistoric diets promoted metabolic flexibility. Periods of abundance alternated with scarcity, requiring the body to adapt to different levels of calorie intake. Humans evolved to efficiently store energy, mobilize fat reserves, and maintain function during lean periods. This flexibility enhanced survival, supporting endurance and cognitive performance even when food availability fluctuated. Modern humans, with constant access to calorie-dense foods, often lack this adaptive advantage, contributing to metabolic disorders. The relationship between diet and social health is also noteworthy. Sharing food, gathering collectively, and hunting together reinforced social bonds and community cohesion. Access to nutritious foods was a social enterprise as much as an individual effort, teaching younger members how to identify, prepare, and process food not only ensured survival but also created cultural continuity and group identity. Health was not only physical but also social, embedded in the practices and knowledge of the community. Injury and recovery were also affected by diet. Protein-rich meat, bone marrow, and mineral-laden plant foods provided the materials for tissue repair. Individuals recovering from wounds or illness relied on the naturally nutrient-rich foods available to regain strength. The combination of variety, accessibility, and nutrient density made prehistoric diets remarkably effective at supporting the body's healing processes. Mental health may have been influenced indirectly by diet as well. Stable energy intake, micronutrient sufficiency, and social meals likely contributed to mood regulation, cognitive clarity, and stress management. While we cannot know the full psychological experience of early humans, the correlation between balanced nutrition and well-being is well established even today. A diet that meets physical needs also supports mental resilience, a principle clearly present in prehistoric life. Finally, the impact of prehistoric diets on long-term evolution is profound. Nutritional choices shaped body size, brain development, digestive efficiency, and even social behavior. Populations that mastered hunting, gathering, and fire-based cooking thrived and expanded into diverse environments. Diet was not merely a matter of survival, it was a driving force in the evolutionary story of Homo sapiens. In conclusion, prehistoric diets had far-reaching effects on health, from physical strength and cognitive development to immune resilience and social well-being. By consuming a diverse array of plants, animals, and processed foods through fire, early humans achieved a balance that supported survival, growth, and evolution. Understanding these impacts gives us a window into the remarkable adaptability and intelligence of our ancestors, revealing that what they ate shaped not only their bodies but the very trajectory of human history. Survival in prehistoric times wasn't just about finding food, it was about mastering the environment. Humans were constantly challenged by shifting climates, unpredictable weather, diverse terrains, and dangerous predators. Their diets, tools, and social behaviors evolved in direct response to these environmental pressures. Adaptation wasn't optional. It was the key to thriving in a world that demanded flexibility, intelligence, and foresight. Early humans displayed extraordinary adaptability in response to geographic diversity. In dense forests, they relied on gathering nuts, fruits, and edible roots, complemented by small game hunting. In open plains, they tracked and hunted large herbivores, developing strategies for coordinated drives and ambushes. Coastal populations relied on fishing, shellfish collection, and even early forms of aquaculture, creating diets rich in protein and essential fatty acids. Mountainous regions presented challenges of altitude, cold, and scarce plant resources. Yet humans in these areas thrived, learning which hardy plants could be consumed and which animals could be hunted effectively. Climate fluctuations played a major role in shaping diets and survival strategies. During warmer periods, plant foods flourished, providing abundant calories and vitamins. Cooler periods, ice ages, or droughts demanded reliance on fat-rich animal sources, preserved foods, and stored plant materials. Humans developed sophisticated knowledge of seasonal cycles, migration patterns, and resource availability, allowing them to anticipate changes and prepare accordingly. Their understanding of the environment was not casual, it was precise, observational, and crucial for life or death decisions. Fire was central to environmental adaptation. Beyond cooking, it provided warmth in cold climates, protection from predators, and the ability to modify landscapes. Controlled burns, for instance, may have been used to clear underbrush, encourage the growth of edible plants, or drive animals into hunting zones. Fire also extended the reach of humans into colder or more challenging regions, demonstrating how a single technological innovation could amplify adaptability across diverse environments. Toolmaking further enhanced adaptation. Stone, bone, wood, and later, composite tools allowed humans to exploit a wide variety of resources. Knives, scrapers, spears, bows, and fishing implements enabled precise interaction with the environment. Tools weren't just conveniences, they were extensions of human skill, allowing people to hunt efficiently, process plants, and survive in regions that might otherwise have been inhospitable. Innovation was constant. Humans observed nature, experimented, and refined tools over generations to meet environmental demands. Mobility was another adaptive strategy. Many prehistoric humans were nomadic or semi-nomadic, moving with the seasons, animal migrations, and resource availability. This mobility allowed them to optimize access to food, water, and shelter while avoiding depletion of local resources. Migration required planning, social cooperation, and detailed knowledge of geography. Humans learned to recognize safe routes, seasonal shelters, and strategic hunting or gathering locations, demonstrating remarkable environmental intelligence. Environmental adaptation also shaped social organization. Groups had to work together to exploit resources effectively. Coordinated hunting, communal gathering, and food-sharing systems emerged, not only out of necessity, but also as strategies to maximize survival. Knowledge of edible plants, hunting techniques, and storage practices was shared within communities, creating networks of learning that ensured group survival. Social cohesion was inseparable from environmental mastery. Diet itself was a reflection of adaptation. Humans consumed foods best suited to their environment: fatty meat in cold climates for energy and warmth, abundant fruits and leafy greens in tropical forests for hydration and micronutrients, and preserved foods in regions with seasonal scarcity. This adaptability allowed humans to inhabit virtually every environment on Earth, from arid deserts to frozen tundras. Long before agriculture made permanent settlements possible, predator and competition pressures also influenced adaptation. Early humans had to navigate the presence of large carnivores, rival groups, and even aggressive herbivores. Hunting techniques, group coordination, and awareness of predator behavior were essential. Knowledge of environmental hazards, rivers, cliffs, or poisonous plants was integrated into daily life. Survival was a constant exercise in risk assessment and strategic decision-making, honing cognitive and physical abilities over generations. Seasonal resource management was another form of adaptation. Humans learned to store food, preserve surplus, and ration during lean months. They used environmental cues to anticipate shortages, such as the ripening of certain plants or the migration patterns of animals. By synchronizing their activities with nature's rhythms, humans minimized risk and maximized nutrition, turning potential scarcity into a predictable cycle rather than an existential threat. Cultural adaptation complemented physical and technological adaptation. Rituals, taboos, and traditions often reflected an understanding of the environment and dietary needs. Certain plants or animals were revered, avoided, or consumed seasonally, reflecting knowledge of ecological balance. These practices, passed down through generations, helped prevent overexploitation, reduce poisoning risks, and ensure long-term sustainability of resources. Culture and environment were tightly intertwined, shaping not only what humans ate, but how they lived, moved, and interacted with the natural world. Environmental pressures also influenced innovation in storage and preservation. Humans discovered that drying, smoking, and roasting foods could extend shelf life, making it possible to endure periods of scarcity. Techniques like catching nuts, burying roots, and preserving meat and fish in smoke demonstrated sophisticated understanding of both biology and chemistry. Long before scientific explanation existed, these innovations enhanced survival and reduced vulnerability to unpredictable environmental changes. The development of cognitive skills was closely tied to environmental adaptation. Spatial memory, observation, planning, and problem-solving were honed through hunting, gathering, and seasonal movements. Early humans had to predict animal behavior, locate edible plants, and navigate challenging landscapes. These mental faculties were not just academic, they were life-sustaining skills, honed daily in the struggle to adapt successfully. Finally, adaptation to environment was cumulative. Every generation built upon the knowledge, experience, and successes of the previous one. Survival strategies, dietary knowledge, and technological innovations accumulated, creating a legacy that allowed humans to inhabit increasingly diverse and extreme environments. Adaptation was not a static skill. It was an evolving, dynamic process, intimately tied to diet, technology, culture, and social cooperation. In conclusion, the story of prehistoric humans is inseparable from the story of environmental adaptation. Humans survived and thrived, not through sheer strength alone, but through intelligence, observation, creativity, and social cooperation. Diet, fire, tools, mobility, and culture all served the same purpose: to master the environment and ensure survival. Understanding this connection illuminates how humans became one of the most adaptable species on Earth, capable of thriving in conditions that would challenge even the most resilient modern societies. In the world of prehistoric humans, food was never guaranteed. Hunting could fail, weather could turn harsh, and seasonal abundance was fleeting. Survival often depended on the ability to store and preserve foods, a skill that transformed unpredictable resources into reliable nutrition. The practices of food storage and preservation weren't just about convenience. They were vital strategies that allowed humans to endure lean periods, travel long distances, and maintain social cohesion. The earliest forms of storage were surprisingly sophisticated. Humans quickly realized that nuts, seeds, and certain tubers could be kept for months if stored in cool, dry, and protected locations. Simple techniques, burying foods in soil, placing them under rocks, or keeping them in hollowed-out logs, extended shelf life and safeguarded against spoilage and scavengers. Seasonal fruits and vegetables could be preserved this way, providing a steady supply of essential nutrients. Even when fresh options were scarce, fire and smoke played crucial roles in preservation. Roasting and smoking meat and fish not only enhanced flavor, but also reduced moisture content, slowing microbial growth and decay. Smoking was particularly effective in colder climates, where drying alone was insufficient. By carefully controlling temperature and smoke exposure, early humans could preserve protein-rich foods for weeks or months, turning short-term hunting success into long-term sustenance. Drying was another widespread technique. Tubers, fruits, and meat could be sun-dried or air-dried to reduce water content, preventing spoilage. In arid or windy regions, this method was especially effective. Drying allowed for lightweight, portable, and nutrient-dense food that could be carried during migrations or hunting expeditions. Imagine a group of prehistoric humans walking miles to follow seasonal game, carrying carefully dried fruits, nuts, and smoked meat, essentially an early version of a backpacking food system. Salt may have been discovered later in some regions, but natural salting techniques were likely used even in prehistoric times. Minerals, ashes, or naturally salty soils could help draw moisture out of foods, further extending their shelf life. Combining salting with drying or smoking created a multi-layered preservation approach that made survival far more reliable, particularly during winter or drought. Fermentation is another fascinating aspect of prehistoric preservation. While harder to prove archaeologically, evidence suggests that early humans may have allowed fruits, grains, or dairy to ferment, producing foods with extended shelf life and enhanced nutritional value. Fermentation not only preserved food, but also enriched it with beneficial microorganisms, potentially supporting digestive health and immunity. These early experiments foreshadowed the sophisticated food preservation techniques developed thousands of years later. Storage wasn't just about extending life, it was also about strategic planning. Prehistoric humans had to anticipate seasonal abundance and scarcity. They gathered more than what was needed immediately, understanding that stored resources would support them when hunting failed, weather turned cold, or plant foods were unavailable. This foresight required careful assessment of resource availability, understanding spoilage risks, and knowledge of environmental conditions. Every cache represented a calculated investment in survival. Storage and preservation also influenced social structures. Resources needed protection, organization, and access management. Groups often designated specific areas for food storage, and sharing was regulated according to social norms, age, or status. Knowledge about which foods could be stored, how, and for how long became a form of social capital. Elders and experienced members often guided these practices, teaching younger generations the skills necessary to survive. Lean seasons. Regional and environmental factors influenced the methods used. In colder climates, freezing could serve as a natural preservative, slowing decay in meat and certain plant foods. In temperate regions, underground caches or cool stream beds were preferred. In arid zones, sun drying and air drying became essential. Humans learned to exploit natural conditions, combining observation and experimentation to develop the most effective preservation strategies for their environment. The benefits of storage went beyond survival. They allowed humans to plan long-term activities. Large hunts could be undertaken without immediate consumption pressure. Migration and exploration were possible, as portable, preserved foods provided reliable sustenance. Even social and ceremonial events were supported by storage practices. As surplus foods could be shared, traded, or consumed collectively, storage was a bridge between survival and cultural development. Interestingly, food preservation also fostered innovation. Humans discovered that certain techniques improved flavor and digestibility. Roasting meat not only preserved it, but made it more palatable. Drying fruits concentrated sugars, providing a sweet energy source. Fermentation added new tastes, textures, and nutritional benefits. Preservation was not just practical, it enhanced the culinary experience, laying the groundwork for the human relationship with food as both necessity and pleasure. Protection from pests and scavengers was another challenge. Humans had to ensure stored foods were safe from rodents, insects, or other animals. Elevated caches, burial pits, or natural barriers were used to prevent loss. These practices required careful observation of animal behavior and environmental conditions, demonstrating an advanced understanding of ecological systems and their influence on food security. Seasonal cycles dictated storage strategies. Autumn, for example, was peak time for gathering and preserving nuts, fruits, and tubers, ensuring winter survival. Hunting in late fall and early winter allowed for meat preservation through smoking or freezing. Communities synchronized their activities with environmental rhythms, creating an organized approach to sustenance that balanced immediate needs with future security. Finally, the ability to store and preserve food reinforced social cohesion. Shared knowledge, collaborative collection, and joint preparation of preserved foods strengthened bonds within communities. Groups that mastered these techniques were more resilient, better able to survive environmental challenges, and capable of expanding into new territories. Storage and preservation were not merely technological achievements, they were deeply intertwined with culture, cooperation, and human ingenuity. In conclusion, prehistoric humans transformed the unpredictability of nature into manageable, reliable resources through storage and preservation. Fire, smoke, drying, fermentation, and strategic catching extended the shelf life of food, supported long-term survival, and enabled migration and social cohesion. These early practices highlight the sophistication, intelligence, and foresight of our ancestors, revealing that even tens of thousands of years ago, humans were capable of remarkable planning and innovation in the quest for sustenance. One of the most remarkable aspects of prehistoric diets was the use of tools and techniques to access, process, and consume food. Early humans didn't rely solely on raw strength or instinct. They were inventive, creative, and incredibly resourceful. Their tools transformed the landscape of survival, allowing them to hunt more efficiently, prepare plants safely, and preserve food for future use. Understanding these tools offers a window into the intelligence and adaptability of our ancestors. Stone tools were among the earliest and most versatile implements. Knives, scrapers, and hand axes allowed humans to cut meat, peel, bark, and shape other materials. A sharp flint blade could turn a large animal carcass into manageable portions, separate edible tissue from bone, or strip plant fibers for consumption. Scrapers helped process hides, but also prepared fibrous roots and tubers for cooking, demonstrating a dual purpose in both sustenance and survival. These tools were crafted with precision, reflecting careful observation, practice, and planning. Bone and antler tools added another layer of sophistication. Needles, awls, and fishhooks made from bone allowed humans to craft clothing, fish efficiently, and manipulate small items with precision. Even simple tools like digging sticks or spades facilitated the extraction of tubers, roots, and bulbs, which were otherwise inaccessible. The ingenuity of toolmaking highlights the human ability to extend physical capabilities, transforming the environment into a source of nourishment and utility. Fire-based techniques were intertwined with tools. Stones could be heated to roast roots, boil water, or cook meat indirectly. Early humans discovered that placing hot stones into pits with food created rudimentary ovens, allowing for even cooking and enhanced digestibility. This technique required knowledge of temperature control, timing, and the properties of different foods, a level of experimentation that reflects both curiosity and practical problem-solving. Fishing and trapping techniques demonstrate remarkable strategic thinking. Nets, lines, and hooks made it possible to catch fish efficiently, while traps, snares, and pits captured small mammals or birds. These methods reduced the energy required for food acquisition, increased reliability, and allowed humans to exploit a wider range of food sources. Hunting large game was risky and resource-intensive, so small game strategies were essential for sustaining communities. Tools and techniques, in this sense, optimized energy balance and survival efficiency. Grinding stones and mortars were essential for plant processing. Nuts, seeds, grains, and roots could be ground into pastes, flours, or meals, making them more digestible and nutrient. This innovation expanded the variety of foods humans could consume and prepared the ground for agricultural practices millennia later. Grinding also demonstrated foresight, as it allowed storage and later consumption of otherwise perishable foods. Shelters and cooking arrangements were themselves a kind of tool. Hearths, pits, and stone enclosures allowed humans to control heat, cook safely, and preserve fire. Stone arrangements in cooking pits facilitated roasting, boiling, and smoking, showing that humans understood principles of heat distribution and food safety long before formal science existed. These techniques illustrate a sophisticated integration of environment, technology, and diet. Hunting, weapons like spears, bows, and otlots revolutionized the human diet. Spears enabled distance hunting of large animals, while bows allowed precision and reduced risk. These weapons required materials, design knowledge, and skillful use. Hunting was not random. It was calculated and often cooperative, involving tracking, ambush, and communication. Techniques evolved regionally, reflecting environmental conditions, prey behavior, and available materials. Preservation techniques were also tool-dependent. Racks for drying meat or fish, pits for storage, and containers for liquids like fats or broths demonstrate creative adaptation. Even simple woven baskets or shelves served as early containers, preventing spoilage and facilitating transport. The combination of tools, techniques, and environmental awareness allowed early humans to exert remarkable control over their food sources. Observation and experimentation were integral to tool use. Early humans had to understand the properties of materials: stone hardness, bone flexibility, wood grain, and how these properties influenced performance. They tested different designs, refined methods, and passed knowledge through generations. Tool-making was thus both practical and educational, enhancing cognitive development, social cohesion, and dietary success. Tools also shaped social structures. Skill in tool-making could elevate status, as individuals who could craft effective hunting weapons or storage containers were invaluable to the group. Knowledge transfer, teaching children or peers how to make and use tools, was essential for survival. Tools were not merely objects, they were extensions of human skill, culture, and intelligence. Even small innovations had large impacts. A sharpened stone scraper could save hours of labor in processing roots. A better crafted spear increased hunting success. A well-placed smoking rack prolonged the life of meat. Incremental improvements compounded over generations, creating a cumulative advantage that allowed humans to thrive in diverse environments. Regional variation also influenced tools and techniques. Coastal populations focused on fishing implements and shell processing tools, while forested areas emphasized digging sticks, traps, and flint knives. Open plains required spear tips designed for large game, while mountainous regions needed tools for climbing, digging, and processing hardy plants. Humans were adaptive engineers, designing tools to meet the demands of their surroundings. Finally, the combination of tools and techniques demonstrates a holistic approach to survival. Humans didn't rely on a single strategy. They integrated observation, tool-making, environmental understanding, and social cooperation to optimize diet and health. Cooking, hunting, processing, preservation, and storage all relied on specific implements, reflecting a complex network of knowledge and skills that underpinned prehistoric life. In conclusion, tools and techniques were essential to prehistoric diets, enhancing efficiency, safety, and nutritional value. From stone knives to bone hooks, hearths to grinding stones, early humans leveraged every available resource to expand dietary options and secure survival. These innovations reflect intelligence, creativity, and adaptability, showing that even tens of thousands of years ago, humans were capable of sophisticated problem-solving that shaped both their diets and the trajectory of human evolution. Hunting was one of the defining activities of prehistoric humans. While gathering plants and fruits provided essential sustenance, hunting large and small game supplied the protein and fat necessary for energy, brain development, and survival in harsh environments. But hunting wasn't random or purely instinctual. It required strategy, teamwork, observation, and patience. Early humans developed sophisticated hunting techniques, shaped by terrain, prey, behavior, and available tools. One of the earliest and most basic strategies was ambush hunting. Prehistoric humans observed animal behavior closely, learning where and when animals traveled, grazed, or drank. By understanding these patterns, hunters could position themselves near watering holes, trails, or feeding areas. They used natural cover bushes, rocks, or tree lines to remain hidden and waited patiently for the right moment to strike. Timing, stealth, and knowledge of prey were crucial. Success was rarely accidental. Cooperative hunting became increasingly common as human groups grew larger. Unlike solitary predators, humans could plan coordinated drives or flanking maneuvers. To guide animals into traps, ambushes, or confined spaces, groups communicated silently or with subtle signals, demonstrating early forms of teamwork and tactical planning. Large game like mammoths or aurochs required not only skill but cooperation, as a single hunter was rarely sufficient to bring down such massive prey. Success depended on synchronization, understanding animal behavior, and the precise use of weapons. The use of tools and weapons dramatically expanded hunting capabilities. Spears allowed humans to attack from a safe distance, reducing risk of injury. Otlots and later bows provided even greater range and accuracy. Stone-tipped spears or arrows could penetrate thick hides, making hunting more efficient. The combination of tools and tactics transformed hunting from a purely brute force activity into a calculated, high-skill endeavor. Trapping and snaring small game were equally vital. Early humans set up snares, pits, and net traps to capture birds, rabbits, and other small animals. These methods were energy efficient and provided reliable sources of protein, complementing the unpredictability of large game hunting. Traps required knowledge of animal behavior, placement, and maintenance skills that were carefully taught and passed down within communities. Hunting techniques varied regionally. In forested areas, ambush and trap strategies dominated, while open plains favored pursuit and endurance hunting. In coastal areas, humans developed specialized methods for fishing, including nets, hooks, and spearfishing. Mountainous terrain encouraged stalking and opportunistic hunting of goats or other cliff-dwelling animals. Each environment demanded adaptive strategies, demonstrating that hunting was not one-size-fits-all but highly context-dependent. Seasonality played a critical role in hunting strategies. Prehistoric humans observed breeding, migration, and feeding cycles of animals to optimize hunting success. Autumn and early winter were often prime times for hunting large herbivores, which were fatter and more nutritious. In contrast, smaller game might be hunted year-round, providing a steady source of protein during lean seasons. Timing was everything. Hunters who ignored seasonal cues risked failure or wasted effort. Tracking skills were central to hunting success. Early humans read footprints, droppings, feeding signs, and environmental cues to locate prey. Tracking required patience, observation, and memory. A skilled tracker could follow an animal for miles, predicting its movements and behavior. This Knowledge was passed from elders to younger hunters, forming a crucial part of cultural and practical education. Energy management was another consideration. Hunting large game required careful planning, as chasing animals indiscriminately could lead to exhaustion or injury. Humans often used drives, ambushes, or cooperative herding to minimize energy expenditure while maximizing reward. They also had to consider environmental factors like terrain, weather, and water availability to ensure that hunting efforts were sustainable and productive. Safety was always a concern. Hunting large animals carried significant risk, including injury from horns, tusks, or defensive attacks. Strategies often included distraction techniques, teamwork, and backup plans to reduce danger. Human intelligence, foresight, and tool use allowed early humans to manage these risks effectively, balancing reward with potential harm. Preparation and knowledge extended beyond the hunt. Prehistoric humans knew how to process meat efficiently, divide portions among group members, and preserve surplus. Hunters had to understand anatomy, ensuring that valuable cuts were not wasted and inedible parts were discarded or repurposed. Successful hunting integrated skill, observation, preparation, and post-hunt processing, forming a complete cycle of sustenance. Even small innovations made a difference. Camouflage, decoys, or constructed blinds improved success rates. Early humans experimented with fire to drive animals into traps or guide movement patterns. Knowledge of predator-prey interactions, environmental patterns, and tool use combined to create highly effective hunting systems. Over generations, these practices became refined, demonstrating cumulative learning and cultural transmission. Hunting was also a social activity. Shared hunts reinforced group cohesion, hierarchy, and division of labor. Success brought prestige and practical benefit, while failures could be instructive, teaching lessons about strategy, risk, and cooperation. Hunting practices were woven into cultural narratives, rituals, and community identity, showing that food acquisition was both practical and social. Finally, hunting strategies were not static. Humans continuously adapted to changes in climate, prey populations, and technological innovations. Extinctions, migrations, and environmental shifts demanded flexibility and creativity. Groups that could innovate, share knowledge, and adjust tactics were more likely to survive and thrive. Hunting was a dynamic practice, reflecting intelligence, adaptability, and an intimate understanding of the natural world. In conclusion, hunting strategies were central to prehistoric diets and survival. From ambush and endurance hunting to trapping, cooperative drives, and innovative tool use, humans developed a wide range of methods to secure reliable nutrition. Hunting required intelligence, planning, observation, and social cooperation, shaping not only diet, but also cognition, culture, and human evolution. Success was not merely about strength, it was about skill, strategy, and adaptability in a challenging and ever-changing environment. While hunting often takes center stage in our imaginations of prehistoric life, foraging was equally vital. Plants, seeds, fruits, nuts, roots and tubers formed the foundation of early human diets in many regions. Far from being secondary or supplemental, plant foods were abundant, diverse, and nutritionally significant. Understanding prehistoric foraging practices reveals the intelligence, observation skills, and ecological knowledge that allowed humans to thrive across the globe. Foraging was not a haphazard activity. Early humans observed the environment carefully, noting which plants were edible, which were toxic, and which were nutritious. Knowledge was accumulated over generations, often transmitted orally. Mistakes could be fatal, so accuracy was essential. Communities developed sophisticated rules, taboos, and cultural practices to ensure safe consumption of wild plants, demonstrating a combination of trial and error, learning, and social regulation. Seasonality defined foraging patterns. Different fruits, nuts, and roots became available at specific times of the year. Humans adapted their schedules to harvest foods at peak ripeness, ensuring maximum nutrition and flavor. In some cases, they engaged in selective harvesting, taking only what was needed to preserve future growth. This careful management reflects an early understanding of sustainability and ecological balance. Roots and tubers were a staple in many prehistoric diets. These underground storage organs provided carbohydrates, fiber, and essential nutrients. Digging sticks, simple spades, and careful excavation techniques allowed humans to extract these resources efficiently without damaging future growth. Some tubers required processing to remove toxins or increase digestibility, reflecting advanced knowledge of plant chemistry and preparation methods. Cooking often enhanced nutrient availability, transforming tough, fibrous roots into edible and energy-rich foods. Fruits and berries were another key component. Easily harvested, nutrient-dense, and calorie-rich, they provided essential vitamins and hydration. Humans learned which species were edible, which parts were safe, and which seasons were optimal for collection. Fruit foraging often required memory and spatial awareness, as different species ripened at different times and in specific locations. This knowledge formed a critical part of daily life and survival strategy. Nuts and seeds provided concentrated energy and fats. Early humans recognized their high caloric value and developed methods for harvesting, cracking, and sometimes storing them for later consumption. Nuts could be ground into pastes or eaten raw, offering flexibility in preparation. Seeds, though small, contributed essential micronutrients and supported energy needs during lean periods. These foods were reliable, portable, and often stored for months, complementing the unpredictability of hunting. Leafy greens, herbs, and shoots added micronutrients and variety. Early humans understood that different plants offered unique vitamins, minerals, and medicinal properties. Some species were used not just for food but for healing or ritual purposes. Knowledge of plant properties extended beyond nutrition, reflecting a sophisticated understanding of natural resources and their applications in health, medicine, and culture. Foraging required strategy and risk assessment. Some plants were difficult to reach, protected by thorns, or located in dangerous terrain. Humans had to balance caloric expenditure with nutritional gain. Observation of plant growth patterns, soil conditions, and seasonal changes informed decisions. Groups often divided labor, with some members gathering high-risk resources while others collected easily accessible foods, maximizing efficiency and safety. Preparation techniques enhanced the utility of plant foods. Roasting, boiling, and grinding transformed otherwise indigestible or toxic foods into safe, edible options. Some roots and seeds required leaching or fermentation to remove harmful compounds. These practices required knowledge, skill, and careful attention, demonstrating that plant use was far more sophisticated than raw consumption. Cooking plants not only improved digestibility, but also unlocked additional nutrients, supporting health and energy needs. Storage of plant foods was equally important. Nuts, seeds, dried fruits, and tubers could be stored for months, providing a reliable buffer against scarcity. Underground caches, drying racks, and natural shelters were used to protect food from pests and spoilage. These storage practices allowed humans to endure lean seasons, migrate efficiently, and plan long-term activities. The combination of foraging, preparation, and storage created a stable nutritional foundation. Foraging also shaped social dynamics. Knowledge about edible plants was often specialized, with certain individuals recognized for their skill and memory. Sharing of gathered foods reinforced social bonds and created networks of reciprocity. Communities thrived when foraging knowledge was disseminated, preserved, and respected. Food was not just sustenance. It was a medium for teaching, bonding, and cultural continuity. Environmental adaptation influenced plant use. Humans learned which species thrived in specific habitats, forests, wetlands, grasslands, or coastal areas, and timed collection accordingly. Some groups may have even practiced early forms of cultivation or management, encouraging the growth of preferred plants. This blurred the line between foraging and proto-agriculture, reflecting foresight, experimentation, and ecological understanding. Medicinal and ritual uses of plants complemented dietary practices. Certain herbs, roots, or berries had healing properties, acting as natural remedies for digestive issues, infections, or inflammation. Some plants were incorporated into rituals, ceremonies, or symbolic practices, connecting sustenance with cultural and spiritual life. This demonstrates that plant use was multifaceted, bridging nutrition, health, and cultural expression. Finally, plant foraging fostered learning, observation, and innovation. Identifying edible species required memory, attention to detail, and pattern recognition. Experimenting with preparation and storage encouraged trial and error learning and cumulative knowledge. Early humans developed an intimate understanding of ecosystems, interdependencies, and seasonal rhythms, embedding ecological intelligence into daily survival. In conclusion, foraging and plant use were central to prehistoric diets, providing nutrition, energy, and micronutrients while shaping social, cultural, and ecological knowledge. Early humans demonstrated remarkable skill, observation, and innovation, transforming natural resources into reliable sustenance. Their mastery of plants complemented hunting and storage strategies, creating a comprehensive survival system that allowed Homo sapiens to thrive across diverse and challenging environments. In prehistoric times, humans didn't have grocery stores, refrigerators, or year-round access to the foods we take for granted today. Survival depended on understanding seasonal rhythms and migrating strategically to ensure reliable access to nutrition. Seasonal diets and migration patterns were intertwined, shaping not only what humans ate but how they lived, moved, and organized their communities. Seasons dictated food availability. Spring and summer offered an abundance of fruits, leafy greens, tubers, and young animal prey. Early humans took full advantage of this period, gathering and hunting intensively to accumulate reserves. Autumn was a critical season for nuts, berries, and fat-rich game, preparing for the scarcity of winter. Winter and early spring, by contrast, demanded reliance on stored foods, dried meats, cached tubers, and preserved fruits. This cyclical approach required foresight, observation, and planning, as failing to anticipate seasonal scarcity could mean starvation. Migration was often a natural response to seasonal variation. Humans followed animal herds, which moved in search of grazing lands, water, and shelter. Tracking migratory patterns allowed humans to exploit large game efficiently, ensuring a steady supply of protein and fat. Groups also moved to harvest seasonal plant resources, like coastal communities exploiting shellfish in spring or forest dwellers collecting nuts in autumn. Migration was not random wandering, it was a deliberate, knowledge-driven strategy to maximize survival. Diet composition shifted with the seasons. During periods of plant abundance, diets were rich in carbohydrates, fiber, and vitamins from fruits, leaves, and roots. Hunting supplemented this with protein and fat. In lean seasons, reliance on preserved or stored foods increased, with protein and fat from stored meats or nuts becoming essential energy sources. The ability to switch between dietary sources depending on availability reflects remarkable nutritional flexibility and environmental intelligence. Seasonal migration also required logistical planning. Humans had to transport tools, preserved foods, and knowledge about resource locations. Family groups or larger communities coordinated movements, often following traditional routes passed down through generations. These routes were mapped in memory and oral tradition, reflecting detailed spatial awareness and environmental literacy. Understanding geography, water sources, and terrain was crucial to safe and efficient migration. Environmental observation was integral to seasonal strategies. Humans watched plant phenology, animal behavior, and climatic cues to anticipate optimal times for harvesting or hunting. For example, the ripening of berries or the shedding of leaves signaled specific actions, while animal migration or mating seasons indicated hunting opportunities. These observations were cumulative knowledge, refined over generations, linking diet directly to ecological awareness. Seasonal strategies also influenced social organization. Tasks were divided according to age, skill, and physical ability. While some members hunted migratory herds, others gathered plant foods or managed storage caches. Seasonal abundance allowed for communal feasts, strengthening social bonds and reinforcing cultural practices. Scarcity required careful rationing, collaboration, and sometimes even relocation, highlighting the interdependence of survival, diet, and community cohesion. Adaptation to seasonal change demanded innovation. Preservation techniques, smoking, fermenting, or catching allowed humans to bridge gaps between periods of abundance. Clothing, shelters, and fire management were adjusted to environmental conditions, enabling safe migration across harsh landscapes. The combination of food strategies and environmental adaptation demonstrates the ingenuity and resilience of prehistoric humans. Migration was not only about survival, it also facilitated cultural exchange. Groups moving seasonally often encountered other communities, exchanging knowledge, tools, and sometimes even food resources. These interactions enriched collective survival strategies, spreading innovations in hunting, foraging, and preservation across regions. Seasonal mobility thus contributed not only to nutrition, but to the broader evolution of human culture. Dietary diversity was essential for health during seasonal changes. Humans consumed different foods in different seasons, ensuring a wide range of nutrients across the year. This natural dietary rotation prevented micronutrient deficiencies and supported robust physical and cognitive health. Unlike modern diets, which can be monotonous and processed, prehistoric diets naturally balanced macronutrients and micronutrients through seasonality. Energy management was also crucial. Migration required physical endurance, and seasonal foods were chosen to maximize caloric return relative to effort. High-energy plant foods like nuts and fat-rich animal meats were consumed strategically, ensuring sufficient reserves for long treks or hunting expeditions. Prehistoric humans were highly attuned to energy economics, balancing effort with nutritional reward. Even spiritual or ritual practices were linked to seasonal diets. Certain feasts or ceremonies coincided with harvests, hunting success, or migration milestones. Food became a symbol of survival, prosperity, and connection to the environment. These rituals reinforced knowledge transfer, community cohesion, and respect for natural cycles. Eating was not just sustenance, it was cultural, spiritual, and deeply embedded in the rhythm of nature. Finally, seasonal diets and migration illustrate the adaptive intelligence of early humans. They were not passive participants in their environment, but active strategists, anticipating change, exploiting opportunity, and planning for scarcity. Mobility, observation, and foresight were as critical as hunting skill or foraging knowledge, shaping the trajectory of survival and evolution. In conclusion, prehistoric humans mastered the cycles of nature through seasonal diets and migration. Understanding the timing, availability, and nutritional value of resources allowed humans to survive and thrive in diverse and changing environments. Their flexibility, planning, and observational intelligence ensured that, even in harsh conditions, food security and social cohesion could be maintained. Seasonal rhythms were not obstacles, they were the blueprint for survival, shaping human behavior, diet, and cultural evolution. Food in prehistoric times was far more than mere sustenance. While survival depended on calories, protein, and nutrients, the act of eating carried deep social, cultural, and symbolic meaning. Meals were intertwined with rituals, social hierarchies, teaching, and community bonding, making diet a central pillar of human life. Beyond physical survival, sharing food was one of the earliest expressions of social cohesion. Communities relied on collaborative hunting, gathering, and preservation, and the distribution of food reinforced social bonds. Those who brought back large game or abundant harvests gained prestige, while equitable sharing ensured group survival. Meals became communal events, fostering trust, cooperation, and reciprocity. Through these practices, food became a medium for social structure, teaching values of fairness, skill, and generosity. Rituals and ceremonies often centered around food. Certain animals, fruits or grains, were consumed in ceremonial contexts, marking seasonal events, successful hunts, or rites of passage. The preparation and consumption of these foods reinforced cultural norms, collective identity, and spiritual beliefs. Some foods may have been symbolic, representing fertility, prosperity, or connection to ancestors, while others were used to honor deities or natural forces. Food was a bridge between the tangible and the spiritual world. Food also carried lessons and knowledge. Elders and skilled foragers taught younger members which plants were safe, how to prepare tubers, or how to track and hunt animals effectively. Every meal became an opportunity for practical education, transmitting survival skills and ecological knowledge across generations. Knowledge of seasonal availability, preservation, and nutritional value was embedded within the act of eating, ensuring that cultural wisdom was as nourishing as the food itself. Preparation techniques were culturally significant. The way foods were cooked, smoked, roasted, or ground reflected tradition, experimentation, and learned skill. Communities developed distinct preferences and methods, creating early forms of culinary identity. For example, roasting meat over fire, fermenting fruits, or grinding nuts into paste may have been more than practical. They were cultural markers that distinguished one group from another. food preparation became an art intertwined with survival. Food also influenced social hierarchy. Those skilled in hunting, gathering, or preservation often gained status. Leaders, elders, or shamans may have controlled or distributed high-value foods, reinforcing social roles and authority. Ritual meals, feasts, and surplus distribution highlighted power structures, yet also strengthened communal cohesion. Food was both a tool for survival and a mechanism for organizing society. Symbolism and taboo surrounded certain foods. Some plants or animals were avoided for spiritual, medicinal, or cultural reasons. Others were reserved for special occasions or specific individuals. These practices were not arbitrary. They reflected ecological knowledge, health considerations, and social norms. Taboos helped prevent overexploitation, avoided dangerous species, and reinforced cultural identity, demonstrating that prehistoric diets were shaped by both nutrition and belief systems. Feasts and celebrations provided opportunities for social bonding. Success in hunting or gathering was celebrated through shared meals, storytelling, and ritual. These communal events reinforced alliances, resolved conflicts, and strengthened group identity. Food became a medium for memory, emotion, and cultural expression, linking survival with joy, prestige, and community connection. Food and culture were also connected to innovation. Experimentation with cooking, preservation, and preparation was often shared, creating cumulative knowledge that shaped dietary evolution. Communities that innovated effectively were more resilient, spreading techniques and cultural practices to neighboring groups. Culinary ingenuity became a form of adaptive intelligence, enhancing both nutrition and social cohesion. Medicinal and functional uses of food further emphasized its cultural importance. Certain plants, fats, or animal parts were consumed for healing, boosting immunity, or enhancing strength. Knowledge of these properties was highly valued and often held by elders or shamans. Food was thus a medium for health, education, and spiritual connection. Deeply integrated into daily life, food influenced migration and settlement patterns as well. Availability of specific plants and animals dictated routes, timing, and the location of temporary or permanent camps. Groups adjusted movements according to dietary needs, ensuring sustainable access to essential resources. This strategic use of food reinforced cultural traditions, knowledge transfer, and environmental intelligence. Culinary practices also shaped identity. Each group developed preferences, preparation methods, and consumption patterns, creating a sense of belonging and distinction. Sharing meals reinforced cultural cohesion, while differences in diet marked group boundaries. Food became a marker of history, tradition, and survival, linking individuals to place, ancestors, and community. Even storytelling and myth-making were tied to food. Tales of hunts, abundant harvests, or dangerous foraging expeditions became shared narratives, blending entertainment, education, and survival guidance. Food stories reinforced practical knowledge, cultural values, and collective memory, turning meals into lessons, rituals, and expressions of identity. Finally, food in prehistoric times reflects the inseparability of survival, culture, and intelligence. Humans didn't just consume, they observed, experimented, taught, celebrated, and ritualized. Diet was a central axis around which social structure, learning, mobility, and spiritual life revolved. By understanding the cultural significance of food, we gain insight into the cognitive, social, and emotional sophistication of early humans. In conclusion, prehistoric diets were more than nourishment, they were a cornerstone of culture. Sharing, preparation, ritual, and innovation transformed food into a medium for education, identity, spirituality, and community cohesion. Survival and culture were intertwined, and understanding this interplay reveals the depth of human intelligence, adaptability, and social complexity tens of thousands of years ago. The story of prehistoric diets is not just a tale of survival, it is a story of innovation, adaptation, and the foundation of human culture. Every decision about what to eat, how to process it, and when to move shaped the trajectory of human evolution, leaving lessons that resonate even today. By studying the foods, strategies, and cultural practices of our ancestors, we can understand the roots of human resilience, intelligence, and social complexity. Prehistoric diets left a lasting legacy in multiple domains: nutritionally, humans learned to balance macronutrients and micronutrients in ways that modern diets often struggle to replicate. By combining hunting and foraging, storing and preserving, they created diverse, energy-rich, and micronutrient-dense meals that sustained both physical and cognitive development. Their diets supported brain growth, endurance, and health, enabling humans to thrive in challenging environments and spread across continents. Technological innovation was intertwined with diet. Stone tools, bone implements, fire management, and preservation techniques allowed humans to manipulate their environment to meet nutritional needs. Each improvement: sharper spear points, more efficient grinding stones, better smoke racks enhanced survival, demonstrating the cumulative nature of human innovation. These tools also laid the groundwork for future technological advancements, including agriculture, pottery, and metallurgy. The social implications of prehistoric diets were profound. Food-sharing practices, cooperative hunting, and communal gathering reinforced social cohesion, hierarchies, and teaching. Knowledge about edible plants, animal behavior, and preservation techniques was transmitted across generations, ensuring survival and cultural continuity. Diet was thus not only a biological necessity, but also a medium for communication, education, and social bonding. Observation and adaptation were central lessons. Early humans were constantly learning from their environment, adjusting diets according to seasonal abundance, migration patterns, and ecological changes. They mastered the cycles of nature, anticipating scarcity and exploiting opportunity. This ecological intelligence, combining observation, memory, and experimentation, was critical for survival and provides a model for modern sustainability and environmental awareness. Flexibility and resilience defined prehistoric diets. Humans were not tied to one food source or one method of preparation. Hunting, gathering, storage, preservation, cooking, and fermentation were all part of an integrated system that allowed them to respond to environmental fluctuations. This adaptability enabled them to inhabit deserts, tundras, forests, and mountains, proving that survival depended on creativity and versatility as much as strength or stamina. Cultural practices around food influenced identity, rituals, and traditions. Meals were moments of learning, teaching, celebration, and spiritual connection. Knowledge about safe and nutritious foods, preparation techniques, and seasonal cycles was embedded in stories, taboos, and rituals. Food shaped values, reinforced norms, and provided meaning beyond sustenance. This intertwining of diet with culture shows the depth of human cognition and social complexity, revealing that prehistoric humans were not only survivors but thinkers, learners, and innovators. Prehistoric diets also highlight the importance of long-term planning. Storage, preservation, and understanding seasonal rhythms demonstrate foresight. Humans thought beyond immediate needs, developing strategies to ensure food security across days, months, and years. This planning required memory, coordination, and communal cooperation, laying the foundation for later innovations like agriculture, trade, and urban settlement. Health and nutrition were closely tied to these practices. Diverse diets, seasonal variety, and careful preparation prevented deficiencies, enhanced digestion, and supported immunity. By balancing plant and animal foods, humans optimized energy intake and nutrient diversity. The interplay of diet, activity, and environment contributed to physical fitness, endurance, and survival lessons that modern nutrition still echoes today. Migration and mobility reinforced the lessons of diet. By following resources, humans learned geography, ecology, and animal behavior. Seasonal movements required knowledge of safe routes, water sources, and resource locations. These movements facilitated cultural exchange, technology diffusion, and social networks. Food was not just sustenance, it was a driver of exploration, learning, and human connectivity. Even the cognitive and creative capacities of humans were shaped by diet. Hunting, foraging, and food preparation demanded observation, problem-solving, experimentation, and memory. Tracking prey, identifying edible plants, or perfecting preservation methods engaged the brain in complex, integrated tasks. This dietary intelligence fostered innovation, planning, and cultural transmission, shaping the evolution of human cognition. Prehistoric diets also teach us about sustainability. Humans relied on renewable resources, observed ecological limits, and developed practices to ensure long-term availability. Selective harvesting, seasonal consumption, and preservation were early forms of resource management. Understanding and respecting these natural cycles allowed humans to survive for millennia without depleting their environment. Lessons increasingly relevant in today's world of ecological challenges. Finally, the legacy of prehistoric diets reminds us of human resilience and ingenuity. Faced with unpredictable climates, scarce resources, and dangerous landscapes, humans survived by observing, innovating, cooperating, and adapting. Their strategies were practical, scientific, and cultural, blending intelligence, creativity, and social cohesion. The story of prehistoric diets is a story of humanity itself, inventive, and deeply connected to the natural world. In conclusion, the diets of prehistoric humans were far more than a matter of survival. They were a catalyst for technological innovation, cultural development, social cohesion, ecological intelligence, and cognitive evolution. By studying these diets, we gain insight into the origins of human resilience, adaptability, and creativity. The lessons are clear: observation, flexibility, cooperation, and understanding our environment are timeless keys to survival and flourishing. Prehistoric diets remind us that food is not just fuel, it is knowledge, culture, strategy, and legacy, shaping who we are and how we continue to thrive as a species.